All right, hello everyone. This video is going to continue our discussion of Module 4B, which concerns the scientific study of judgment, decision making, and reasoning. And in this particular video, I'm going to be talking about something called framing effects. The next question I asked you guys to complete on your worksheet was I wanted you to choose between 4 options, right? So the question says, imagine that the United States is preparing for an outbreak of an unusual disease that is expected to kill 600 people, okay? Perhaps this particular example hits a little bit close to home for all of us, but we'll charge ahead. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the programs are as follows. If program A is adopted, 200 people will be saved. If program B is adopted, there is a 1/3 probability that 600 people will be saved and a 2/3 probability that no one will be saved. Which of the 2 programs would you favor? Now consider the following additional proposals for combating the same disease. If program C is adopted, 400 people will die. If program D is adopted, there is a 1/3 probability that nobody will die and a 2/3 probability that 600 people will die. Okay? Which of these programs would you pick? Right? So first you're choosing between A and B, and then you're choosing between C and D, right? So which programs did you guys pick? So the first thing to notice here, if you haven't noticed already, is that if we look closely at these 4 programs, there's actually identical pairs, right? So for example, in program A and program C, 400 people die, right? So in both programs, 400 people die, yet 72% of people chose program A, while only 22% of people chose program C, right? Similarly, program B and program D result in the exact same number of deaths, and yet 78% of people chose program D, while only 28% of people chose program B. So what is going on here? If it results in the same outcome, why are people choosing the programs at such a different rate, right? Well, Tversky and Kahneman, when they conducted this experiment in 1981, they proposed the following theory to explain it. So it was basically the idea that the reason why the rates of endorsement are so different are because of the way that the choices are stated or framed. Okay? So when participants were asked to choose initially between program A and program B, right? The choice is framed in terms of gains, right? So people are made to think about the possible benefits of enacting this program, right? So if you choose this program, 200 people are going to be saved, right? So because the question or the choices given are framed in terms of benefits or in terms of gains, people want certainty, right? So when people are thinking about the possible benefits or gains that they'll incur by adopting a particular strategy, they want the outcome to be as certain as possible. Okay? And another way of saying they want the outcome to be as certain as possible is they're adopting a risk aversion strategy. Okay? So they don't want to risk any people. They want the most certain strategy. Right? However, even though the number of deaths is exactly the same, right? When participants are asked to choose between program C and program D, those choices are framed in terms of losses, or they're framed in terms of the number of deaths, right? And we don't like loss, right? You want to avoid loss at pretty much all costs, right? So in that case, because we're extremely motivated to avoid potential losses, okay, we're willing to risk more, okay? So now we're not as concerned about certainty. We just want to do everything we possibly can to avoid possible losses, right? So in that case, we're willing to take the riskier option, right? Or when things are framed in terms of losses, we're willing to adopt a more risk-taking strategy, right? So we're willing to gamble on the fact that there's a 2/3 of a chance that 600 people will die, rather than choosing a certainty that 400 people will die, right? So we like the certain option when we're made to think about it in terms of the number of lives saved, right? But we're willing to avoid losses at all costs, right? And in that case, we don't want the certain option. We want to do everything we can to avoid the possibility of a loss. So we're going to take the risk-taking strategy in an effort to avoid the potential for loss. Okay? So framing effects just mean the way that the choices are stated, whether they're stated in terms of gains or losses, is going to determine what we choose, even if the number of deaths or the outcomes are identical. Okay? So when something is framed in terms of gains, we crave certainty and we'll choose a risk aversion strategy to be certain that we're going to gain something, right? Whereas when it's framed in terms of what we lose or what gets taken away, we're willing to gamble and take a much more risky option or risk-taking strategy to avoid those losses. Okay? So just to recap, we have defined judgment, decision-making, and reasoning, and we have talked about various heuristics and biases that often lead us astray and make us less efficient or less effective decision makers. So we've talked about the fact that we often deem things that come to mind easier to be more probable than things that don't come to mind as quickly. We tend to choose we tend to assume that individuals who have more of the characteristics that we typically ascribe to a particular category to be more representative of that category while not taking into account things like base rate. We tend to forget that not all samples represent the population and that the size of the sample matters. And we also tend to adopt different strategies depending upon the particular way that a question is framed. Okay, So that's just a very quick summary for all of you. Certainly, if you have any questions, do not hesitate to contact me, and I will see you guys soon.